This video will provide a short overview of the proposed inner channel leading from Isla de Muertos to the proposed dock site for Puerto and highlight the related dredging requirements. The channel has a length of 7 nautical miles or 13 kilometers and can be divided into 3 equally sized segments, each with unique maneuvering characteristics and dredging requirements. In the lower portion of the screen, a 150-meter long container vessel is sitting in the planned route. Note that the horizontal width of 100 meters is highlighted in green color, and this is 50 meters either side of centerline. Anywhere that requires dredging is highlighted in purple color. The first segment of the route is the eastern portion of the transit. A large portion of this route segment has depths of at least 5 meters, and the areas shown in green have depths of at least 6.0 meters at mean low water. As we get to the northern end of the eastern segment, it does start to shallow a little bit, and then as we move towards the central segment, depths shallow up to 3 meters to 3.5 meter range. The central portion of the channel is naturally the deepest and widest, and would actually lend itself to a two-way traffic meeting area with a small amount of dredging on the north and south side. Subsequently, if one-way traffic is only required, then no dredging would be required at all in this depth segment in order to achieve controlled depths of 6.0 meters at mean low water. Finally, the northern segment of the transit, the last third, is the shallowest and most meandering, with two 45-degree turns coming in short succession of one another. Initially, depths range from 4.5 to 5 meters, but then shallow to less than 3 meters in some areas. This will be the portion that requires the most extensive amount of dredging. Next, we'll look at a recorded simulation run, which will play back at 20 times speed. Note in the presentation that although the dredged channel is depicted as a series of straight lines, the ship for much of the transit is actually turning, particularly in the curves at the beginning of the channel and in the latter part of the channel. This can be seen as we go through the video, and will alternate between bird's eye view looking down at the ship on the chart, as well as horizontal views out the window and underwater views. In this visual simulation, we can see how it would look as we come from the naturally deep channel into the controlled channel that would require dredging. We actually have to make a total of about a 60-degree sweeping alteration of course, coming from the deep channel into the shallower water. And as we can see here from the underwater profile, the channel at a certain stage will require dredging as it starts to shallow once we get between the buoys. Switching back to the chart view, you'll see that as we come out of the sweeping turn, we have a relatively straight segment passing Isla Mono, and then another left-hand turn or port turn, which takes us into the long straight reach leading into the central portion of the transit segment. As the ship steadies on this long straight westerly track segment, we can see how the channel naturally widens and provides more than ample space for two-way meetings of vessels. This would allow us to have one outbound and one inbound vessel on each successive tide, meeting without any difficulty in this area. As mentioned before, dredging is not required to create a one-way channel, so this could be an optional component that is added later on, for example, when maintenance dredging is done, in order to dredge out the areas that are depicted in purple as you see the ship making the turn now coming around this bend, which we're calling Miranda Bend. This naturally wide portion of the channel provides us an overall distance of approximately 1.5 kilometers where two-way traffic would be possible. As we're near the western end of the central portion, we then enter into the northern segment, making another 45-degree turn to starboard, followed subsequently by another turn of 45 degrees. As mentioned previously, this is the shallowest and most meandering portion of the transit. Also note as you watch the last portion of the video that for the last third of the transit, the ship is turning almost continuously, initially to starboard and then followed by a reversal in direction of a S-type bend from 45 degrees to starboard, back 45 degrees to port, and then steadying on the final segment of approximately 2 kilometers leading into the area of the intended dock site. The very final segment of the transit is actually quite straight and deepens as the ship approaches the area where the dock will be positioned.